I'm Prabhat Jha. I'm CTO at Wootric. Wootric is a startup. I'm not used to this. There you go. Wootric is a startup which helps you collect customer feedback, and our goal is to basically measure and boost customer happiness. And we do it, and we get the feedback. Our customers use our product to get the feedback from their customers using microservices like NPS, which you may have heard, something called a Net Promoter Score, which is very simple. Ask you like how likely are you to recommend in a scale of 1 to 10 your service to your friend, and then they give you a score, and then basically once you have the score, then they'll explain you why they gave you 5 versus 6 versus 10. So what we try to do is that we have customers who get like hundreds and thousands of feedback from their customers, and it's very difficult to make sense of all those feedback because the volume of feedback is so huge. So basically, the problem we're trying to solve now is that how can we do aggregation to do some analysis for you so that you can get the insight a lot more quickly. And advantage of getting these insights is that you align your company. You align your company towards basically what your customers, care about, basically. We do have some good name brand customers, as you can see, the DocuSigns, Dockers, VMwares. For some reason, we have very good adoption among DevOps companies like Loggly, Docker, New Relic, all of these guys use quite a bit. And so basically, maybe because our developers are more vocal about how they use their product, and they give you lots of feedback, which is good for us. So whether you are using Wootric or somebody else, let's say you have got lots of survey feedback. Now, if you're using NPS or CSAT or CES surveys, basically you're going to have a quantitative feedback and qualitative feedback. If it's quantitative, then it's just a bunch of numbers. You can do Excel reporting, you can do a Tableau, Looker, any kind of thing, and basically you'll be able to see a trend of how your score is going up or down. But the qualitative, because it's actually plain text, and it's very difficult to analyze. So this talk is about what do you do to help solve that problem. So the problem we are trying to solve for qualitative feedback is to basically categorize those feedback into different buckets, do some sentiment analysis of it, and using this concept like categorization and analysis, we can see what are the themes, like if a set of customers like your product, why do they like it? If they don't like your product, why do they not like it, right? And basically be able to give you a sense of what customers are talking about. A concrete example so that you all are on the same page, this is actually a real feedback. The new dashboard looks real good, but charge takes forever to load, and ticket resolution is also taking longer these days than in the past. If you were to manually classify this feedback, we will say, okay, this feedback partly talks about the usability of the product, and then it's also about customer support, and then it also talks about performance. And the sentiment is actually mixed because some part of it is positive, some part of it is negative. And not only that, it will be really good if you could highlight which category is being talked positively and which one is being talked negatively. So this is the end goal we're trying to get. So I started with Wootric in 2016, and we realized that we have lots of feedback ourselves, our customers have lots of feedback, and they have been basically manually classifying this feedback to different categories themselves. So what could we do? I have lots of, personally I have a big data background, but I don't have a machine learning background. And we need to use machine learning to solve this problem, so how do we go about it? So I said, let me take a smaller bite at this problem first. So we said, well, when I did some research, sentiment analysis is not a new thing, it's been being done for a long time, so what exists out there? So I started with basically my background is in Java, so I'm going to look for what are the Java tools that exist out there which gives you sentiment analysis. And I found the Stanford NLP library, which is open source, and everything. It has a very good POS. A POS in NLP, you might know, is a part of speech tagging, so it tells you whether it's a noun, verb, adjective, and things like that. And it also allowed you to basically construct a dependency graph where you can see if this is the noun, then which verb it relates to and things like that. And my initial thinking was that I'll be able to leverage all of this to basically come up with a good sentiment for the feedback. So I played with it, deployed it, and it worked well, but it did not really work well for like longer feedbacks and when feedback had mixed emotions. So, and another thing was that because I did not have a machine learning background at the time, I did not know how to basically create a new model, a specific for Stanford library, so that when I get a new feedback and I have new data, I can train it better to give me a better sentiment score for it. So, so that was a good experiment that gave me a good understanding of the problem I tried to solve, but I was still looking for a better solution. And Wootric is like 15 people company. My entire engineering team is like 6 people, and we're trying to solve this problem. So I didn't have a whole lot of bandwidth to basically experiment. So second thing, around the same time, Google Cloud introduced beta version of their natural language API, which basically gave almost everything that Stanford NLP gave to me, except I was just using the API. And it worked for me, and because it was a beta version, when it didn't work, I was able to interact with the team over there and give them the feedback, and basically they would make some changes, which gave us more confidence that sentiment is going to be good. Now, it's very hard problem to solve. Humans speak in a very complex way, so it's not accurate. And one example here, you see the sample feedback. It gives you a lot of information you cannot get on your own. This is very good feedback. But if you feed that with an engine, Google API, it will tell you that it's a negative sentiment, obviously, right? So my point is that with Google, with all this machine learning capabilities, if they don't get it right all the time, then it will have been very difficult for us to get it right at the time. So that's an example. So what we do for this is that we allow our customers to basically manually update the sentiment if they think something is wrong with that. So this is just one part of the problem we're trying to solve, right? Like, what is the sentiment? The real part is the feedback classification. So in the example that I gave earlier, like how do you say it's about UX, UI, documentation, quality, customer support, etc. So my research continues, and obviously there's a hype around AI, and the more I read, the sense I got was that, well, if you are doing supervised learning, then all you need is a bunch of label data, and you can copy piece of code from the internet, and there are lots of them, and basically be able to run the model, and it should be able to basically get a good prediction out of your AI solution. And on top of that, the advantage we have, because we've been in the business for 4 years, and our customers have basically manually categorized lots of feedback. So we have like hundreds and thousands of manually human level data to apply to. So like, well, what could go wrong? We get it, obviously we fail miserably because, categorization was totally wrong, like a lot of time. So at this time, I've hired an intern who knows more about data science and NLP than I do, so we basically look into it, like what had happened. And the biggest reason was the training data quality. So even though our customers spend a lot of time manually classifying those feedback into different categories, the definition, how we think about usability and price and quality is going to be, your definition is going to be very different from somebody else's definition. So there's no consistency. So if your data is not consistently labeled, then machine learning is going to inherit those biases and inconsistency as well. So that was part of it. Second was the skewed distribution of labels. So like some labels, like usability, the price, and quality, we'll find lots of training data for. But something like feature request, customer support, we won't have many. Okay. So basically, that was one other problem. Second thing, we realized that the problem space was too big. My nirvana goal was that we'll build this amazing machine learning algorithm which give a feedback, and we'll classify that into many of them and different categories. That was just not there. Yeah, just some example like why it's even more difficult problem to solve. So the fix is, what we did was that, well, let's narrow down the problem. So when we looked at the data, we realized that the way people talk about a DevOps problem is going to be different from like e-commerce and some other product. but if you train your machine learning model for one set of feedback, for one set of product, then actually it might work. And also we basically shorten the list of categories we can break the feedback into. So instead of initial list of like 20 that we had, we made it like a shorter list so that at least when we give it that categorization, it's more accurate. Second thing was that we needed to have a high quality training data. So instead of relying on our customers, actually, we spent our sprint where entire team, company was actually manually labeling data for a different product category. And we made sure that one person actually works on one product category so that even if there is a bias, at least we know there's bias from that person and we can fix it in the next iteration. We explore different algorithms, started with simple bag of words with different classifiers. That was our first pass. Second pass, we use word to vec with PCA. So basically, you have the vector representation of your word, then you apply PCA to see which vector is more important for that feedback, and then you basically go through different classifier to come up with a score of what the feedback is getting about. Then, as we got more comfortable with machine learning, we moved to LSTM. These are some of the parameters. So the problem basically we're solving is a multi-level classification problem. So that's why the loss function you see is the binary cross entropy and all those other metrics. We also have CNN algorithms as well. Of all, one algorithm worked better for certain tags. Not every algorithm works for all tags, and the reason may be that the kind of training data we have, the volume of training data we have. I don't understand personally how the internals of enough to understand what could be causing this, but I do know that the RNN is not always the best algorithm for this. The CNN is not always the best for us as well. But overall, for our problem space, the CNN gives us the best performance. And I think it's because it's supposed to be the LSTM that should give a better one. I think the reason it works probably, my hypothesis is that the customer feedbacks are very short, and most of the LSTM examples that you see is about the blogs and news articles, and these are very, very small feedbacks. So maybe that's part of it. In production, we run all four algorithms in production, and basically we do cross validation on the fly to see which tag should be applied. Which algorithm should we weigh more for this particular category? That way we know, that our categorization will be better. Regardless of all this, the accuracy is good, but it's not good all the time. So we have made it that simple for our customers to basically update the label. So if our classification engine has applied a category to a feedback that they do not like, they can easily actually update in the UI. As a result, what happens is that we get some new training data all the time. We actually even had implemented this continuous learning / online learning process where our model will get updated and will deploy again. But there's something with the TensorFlow and the Keras session that when you update the model on the runtime, for whatever reason, our classification was wrong. So we don't do it we don't do it live anymore. We do it on a weekly basis. As we get more feedback, we'll basically go through our validation and deploy once a week kind of thing. The hard part of it is that the CI/CD, the training, you basically, in a typical software development, you have the code and you have the input data. When you have machine learning, actually your input data sort of is part of the code because that's how this thing works. So what's the boundary between code and the data? How do you version them properly? This is still something we're trying to figure out as well. Lessons learned, I have only 1 minute left. It is a very hard problem, especially if you have a small number of engineers and so not a whole lot of money to start with. We relied lots on soldiers of giants. So look at the research papers from Google, Microsoft, Facebook. They have done lots of work out there. And most importantly, I told the team that this whole exercise may not go anywhere because we are not an expert yet. So that was very important. And second part, I would say the lessons learned is that algorithms are easy actually. RNN and CNN sound very complex, but the code is somebody has done it for you. the hard part was to how do you have the consistent training data? How do you parse it? What kind of encoding you have to use to make sure that your machine learning algorithm can work better? How do you get lots of human classified data to train your model? Those were actually the harder problem than actually applying certain algorithm, because you can just copy paste and it will likely work. Just the interesting tidbits. For example, Michelle crushed it. This feedback is not a negative sentiment. Customer is saying she really did a good job, but that's one of the example. You need video on how to set up alert. If you just do like a paragraph of words, this will be tagged as video, and it's not about video. It's about documentation actually, right? And lots of feedbacks are going to be very simple words like expensive, cool, and things like that. So how do you physically classify this property in a user scale of that? It's what we ran into. Hopefully this gives some insights into problems we ran into and what we did. That's it.
Thank you.
Question?
Hey, how's it going? So one of the things you mentioned in one of the last slides was how deployment into like a production system is kind of difficult. Can you maybe talk a little bit more about how individual engineers develop, what that process looks like? Are you guys validating your conjectures on like a small set of data? Like, how does that decision get made where you guys go from like LSTM to like CNN? Like, how do you guys actually prove the goodness of this like new algorithm before deploying it into a production state?
Yeah. So the question is like, how do you know that this algorithm is working as expected? And when we get a new training data, how do you validate that it should work? And the way we do it across while we're developing in the beginning and even during the production is we do cross validation. So basically, we have a set of feedback that's human labeled. And the way cross validation would work is that we'll take 90% of those feedback for training, 10% as a test. And this is happening iteratively all the time. So when we get a new set of training data, before we deploy to production, we'll run the same cross validation test again, and only deploy to production if it has passed the threshold, for example. And and that's what we use for every algorithm. And equal to choosing one algorithm versus another. As I say, I do not know why LSTM works better for certain tags, certain categories, and why CNN works for a better one. I don't know why, but we know that it works better for certain categories, and so basically we do this ensemble algorithm where we basically took every output from every algorithm into consideration and gave more weight to certain algorithms for certain categories.
Maybe follow up. Are you guys like developing in Jupyter notebooks, or I wanted to understand?
Yeah. So when we experiment, one of the engineers that I have, he works on the Jupyter notebook. I do pure Python.
Okay.
I don't do. Yeah.
I've got a question. Actually, use the mic for once. Some of those models take a lot longer to train. How big are the corpus that you work with? And do you feel that there's a trade-off when you're productionizing things like this to prefer faster inference models?
Yeah. So question is how big is the data, like how long the training runs. Good thing with text is that the data size is not huge, unlike image or video. So even though you have like 10,000 feedback labeled for a given product category, we still talk about megabytes of data. But the LSTM and CNN actually, even for that scale, actually it takes us like more than 12 hours to run the model, which we would store on S3 and do the versioning and all this stuff.
So are you at a point where you can do hyperparameter optimization?
We already do that. Okay. We already do play with different hyperparameters. For example, with CNN, we'll change the filter size and kernel size to see how it's moving. Yeah. Any other questions?
So you spoke a lot about the supervised learning part of it, which you mostly. I was wondering if you also got a chance to kind of play around with unsupervised one, something like LDA, which is very common in text-to-speech processing or NLP.
Yeah, so we tried LDA. LDA failed for us because, as I said, most of the feedbacks are like 2-line longs. So an LDA is for like topic classification, it's still news articles and blogs. So it doesn't work for us. We do use unsupervised learning, and that I didn't mention here, to basically to do anomaly detection, in the sense that we'll basically cluster words from different feedbacks together and see what is the anomaly. So we do use that for that. Yeah.